Hi, what we are going to do today is 8 and 4, lesson 27, nature of solutions of a system of linear equations. And like some of these lessons that we do, this isn't accurately named. This is only one of 3 things that we're going to do today. In fact, this lesson title is really just a summary of what we've been learning over the last few days. And we're going to learn 2 new things to do today. Also, we're going to learn the other 2 things that we're going to learn is how to solve a system of equations algebraically using substitution. And the other thing that we're going to do is there's a way that you can actually write your own linear equation, system of equations, and this is how we write all our problems. This is how they write them for the book. You start with the answer and then write the problem. And I'm going to show you how we do that because it's one of the homework problems that you have on your assignment, your problem set for tonight. So without further ado, let us move over to our sketch pad and get right to this lesson. This lesson is going to be a little bit longer today. I apologize for that, but that's because there's a lot going on here. So the first thing that we're going to talk about, again, is the summary of what we've been doing. And this is the nature of solutions. What do they mean by the nature of solutions of a system of linear equations? We know that a system of linear equations is two equations. Usually, or, it's really 2 or more, but we're really talking in 8th grade about 2 equations with some number of solutions. Okay, so that's when we're going to talk about this in a little bit. And again, these are the 2 things that are also being taught today. This is really actually the meat of the lesson. This is the new stuff. The new stuff, and we'll get to that in the later slides. On this slide, we're going to lay down this summary of the nature of solutions, just so you can see the summary of where we've been. If you want, just fast forward to the final picture. I'm going to have a little picture over here, and it's going to summarize what we've been learning. So when we talk about the nature of the solutions, we're talking about how many answers, how many solutions do we have? Okay, and we've talked about it. We know that the answer is actually 0, 1, or infinite. This means infinite solutions. Okay, so let's make a little chart here. And again, you can fast forward if you really understand this. Just fast forward to the end where I have the chart drawn, and you'll totally get it. So either we have 0 solutions, 1 solution, or infinite solutions. And we can describe it, we can describe this geometrically. On a graph. Or we can describe it algebraically. We'll do the algebraic ones in a second. If we have 0 solutions, remember, that's parallel lines. Parallel lines, and really geometrically, we're asking the question is how many times do the lines meet? These are parallel lines, so number of solutions, parallel lines never meet. 1, let's go to infinite. Infinite lines, these are the same line. Remember, if you have 2 lines lying on top of each other, they intersect all over the place. They meet, meet in lots of places. And then 1 line, these meet exactly once. Right? Most lines meet just exactly once, unless they're exactly the same line or they're parallel. Okay, so now let's go to algebraically. algebraically, we have a thing called a slope and a y-intercept, right? So if we put lines in a form like, y equals mx plus b, we can say that lines with no solutions have the same slope, and this is what we learned, but different y-intercept. Lines that are the same line, another way of saying it graphically is they write on top of each other, but algebraically you're saying they have the same slope and the same y-intercept. Now, lines that meet exactly once, and we learned this right at the end of lesson 27, they have different slopes. Any lines that have different slopes cannot be the same line, and they're not parallel. So it doesn't matter. So they could have the same y-intercept or different, same or different y-intercept. So the first check is look for the slope. If the slope's different, then they meet exactly once. But if the slope is the same, you got to see if it has a different y-intercept or the same y-intercept to determine whether they have zero solutions or infinite solutions. So this is the nature of solutions of a system of linear equations. That is, how many solutions do we have? On your problem set, there are a few equations where they may be parallel lines or the same line. But most of them have this quality. They meet exactly once. So if you get something weird in your solving of your problem, like you get 0 equals 5, or you don't get x equals a certain number or y equals a certain number, but you get some weird answer, you probably have one of these answers. And I'll briefly hit on that at the end. But you should have learned already how to find these, so I'm not going to reproduce that in this very long lesson. Okay. Again, this is the key, but this is the key to the first part of the lesson. Nature of solutions, 0, 1, or infinite. Okay, let's move on to writing your own system of equations, and then we'll get into solving systems algebraically. Hopefully this made perfect sense. You have this chart in your notes, and you are ready to rock and roll. Now, this is a question. Write a system of equations with 2, 4 as a solution. So this is kind of backwards. Usually you get a system of equations like you get like 2x plus y equals 10 and 4x minus 7y equals 14, and you have to solve for the solution. But that's not what we're doing. Right now you have to write a system of equations, and there are lots of system of equations with 2, 4 as a solution. So how can we do this? Well, the way that we do it is we're just going to create 2 equations randomly. And again, anyone's answer, there are lots of different answers to this problem. But the first thing we have to know that if it has exactly one solution, the first key requirement is that we have different slopes. Okay, so we have to write 2 equations with different slopes that contain 2, 4. And this is something you actually know how to do, because I've just told you the key of how to, here's what you have to do, but you know how to do this. Because if I tell you, so let's make up 2 slopes. So let's make up a slope of 2 and a slope of a half. So now you have to write an equation of a line containing 2, 4 with slope 2. You know how to do this. This is from lessons past. So how do we do it? Well, let's do this one in blue. We'll do this m equals a half in a different color. But we say, well, we know that this is the form of all lines. This is the form of all lines. So if it has a slope of 2 and it contains the point 2 comma 4, I know that 2 comma 4 has to make this true. So I'm going to put a 4 in for y and a 2 in for x, and I'm almost done. So now I say, well, 4, that's my y is 4, equals m is 2, 2 times 2 plus b. So I get y equals 4 plus b. Oh, interesting. So b equals 0. So my first equation has m equals 2 and b equals 0. So my first equation is y equals 2x plus 0, or y equals 2x. All right? So this is an equation of a line containing 2, 4, because if I put a 2 in here and I put a 4 in here, it works, and it has a slope of 2. So I know that this is a solution. So now I have to find another equation, and we'll do this one again. We'll do this one in red, and it will have a slope of 1/2. So I have to find an equation of a line, y equals mx plus b, with the slope of 1/2. X and y have to be 2 and 4, because those are my solutions. So I say 4 equals 1/2 times 2 plus b. 4 equals 1 plus b, so b equals 3. So in this equation, I get y equals 1/2, that's my slope, x plus 3. So this is a system of equations. I've just written a problem. So you can write this problem as a test. Say, hey, to your friend, write an equation, because you know that the answer is 2 comma 4, and you say, what is the answer to this system of equations? And they better come up with 2 comma 4 when they solve it. And they can solve it by graphing or substitution. Substitution is the method we'll learn today. You could have solved it by graphing, and you would get this answer 2 comma 4. So let's do this same thing, writing a system of equations, 3 comma -1 is a solution. Use this same method. Come up with 2 slopes, and I'll give you a hint. I'll give you the slopes to use, just because let's use a slope of 1, and we'll use another one with a slope of 1/3. And we'll use this so that when I solve the problem, that you'll see we'll be using the same numbers. So because if you could use the slope of m equals 10 and m equals 1/5, and you could also come up with a system of equations. But I want to use the same ones that you're going to use, so that when I solve it, you'll see where you went wrong or where you went right. Okay. All right. So I know that 3 comma -1 has to solve my equation, and I know that my first equation has to have a slope of 1. So I go y equals 1. That's my slope. Well, let's just do it from total scratch. Y equals mx plus b, and I know that my m is 1, my x is 3, and my y is -1. So -1 equals 1 times 3 plus b. So -1 equals 3 plus b. So b equals -4. I did that in kind of 2 steps in one. So m is 1, b is -4. So my first equation is y equals 1x minus 4. My second equation, y equals 1/3 x plus b. So y, -1 equals 1/3 times 3 plus b. So -1 equals 1 plus b. b equals -2. So my second equation is y equals 1/3 x minus 2. And so there's my system. This is my system with solution 3 comma negative 1. And that deserves happy cat. Okay, I'm going to give you one more of these on homework help. So remember how to do this. But now we have to move on to the other half of the learning. The other half of the learning from today is how to solve systems algebraically using substitution. Now, I've written the steps out in a lot of words over here. So let's not worry about these words just yet. Let's think about what we're going to try and do. Let's talk about that, then I'll come back to these steps. So you could solve using graphs. Right? This system, you could graph both of these lines. You could find the intersection. You could guess you could check, find the answer, which is an ordered pair, and then you could come back and check your ordered pair against these two equations. You could do that, but we're going to not do any graphing. We're going to do all of this algebraically. And the way that you do it is you want to turn your two equations. The key is to turn two equations in two variables into one equation with one variable. That's the key. Two equations and two variables into one equation with one variable. Now, the way that you do that is we're going to use substitution, which is going to get rid of one of the variables. So look here. So if I have, y equals all of this, and in the second equation I have y equals all of this, and I know that y equals y. These are the same. So I could say y, right? If these are the same, then these have to be the same. Right? That's just straight common sense. So I'm going to set these two equal. So what I'm doing is what they call substitution. Right? So I'm going to substitute this thing in for this y. So I'm going to get the equation 2x plus 3 equals 1/2 x plus 6. Right? Because I know that y is this, and I know that y is this. So if y is both of them, then they have to be equal. So hopefully that makes sense to you. If that didn't make sense, send me a note. I'll try and explain it better, but I think that's pretty straightforward. So now I have an equation. Look at what's neat about this. Right here, I had a system, and I've just turned that now into a normal equation that you knew how to solve back at the beginning of the year. So how do you solve this thing? Well, I like to get rid of fractions, so I'm going to multiply everything by 2. And so I get 4x plus 6 equals x plus 12. Why did I multiply everything by 2? To get rid of this fraction. We can't forget all of these little tricks on solving, because those were building blocks. When we were solving these kinds of equations with fractions in them, those building blocks are critical for solving systems of equations. Now we're cooking with gas, because we can subtract x from both sides, and we get 3x plus 6 equals 12. Subtract 6 from both sides, and we get 3x equals 6. And so we get x equals 2. Now, are we done? Well, no, the answer is no, we're not done, because we haven't found out what y is. A system of equations has to have an x and a y. So we take this 2, and we can substitute it back into either equation to find y. So let's do it in this one, because this equation doesn't have a fraction. So let's write it. Y equals 2x plus 3. And we know now that x is 2. So we say y equals 2 times 2 plus 3. So y equals 7. So our answer is 2, 7. And what we can do just to check it is we go to the other equation that we didn't substitute in, and we can check. And I'll do my check step in green here. So y equals 1/2 x plus 6. So does 7 equal 1/2 of 2 my x plus 6? So does 7 equal 1 plus 6? And the answer is yes. So what do we lay down? We lay down a happy cat. So our answer, 2, 7, yay, happy cat. Now these steps over here are just a summary of what we did. So we identified the variable for substitution. And in other problems, these first 2 steps are going to become critical. So here, the problem is set up neatly because I have y. I know that y is what I'm going to do my substitution on because, and so we'll look at the steps 1 and 2 and see why they're necessary later on. So, and even 3, the coefficients of the isolated variable. So I have this what I'm calling an isolated variable, which is my y, and the coefficients are the same. So I can just substitute the other sides for each other. So kind of forget about 1 through 3 if that didn't make any sense. So 4, this is where we kind of started. We substituted and solved for one variable. So because these are the same, I could take my other side here, my 2x plus 3, and I could set it equal to my 1/2 x plus 6. So that was step 4. When I went from here to here, this was step 4. Solving, this was all step 5, where I solved for this variable x. No, sorry, that was step 4. Step 4 was I substitute and I solve. Sorry, this whole thing was step 4. I substituted, then I solved and got x equals 2. So this was the end of 4. And then 5 was the process of substituting this number back in and then solving to get my y. Okay. So we're going to do this a couple more times, and then hopefully we'll all make perfect sense. So let's do another one. And this one's going to be a tad more involved. It's going to involve steps 1, 2, 3, 4, 5, and 6. So on this problem, we need to identify which of these variables is easy to solve for, because in the last one we had y equals 2x plus 3, and I had y equals 1/2 x plus 6, and I knew that y is equal to y, and so I could substitute and make these other two equal to each other. In this one, I can't quite do that because I don't have a y equals this and a y equals that. So let's figure out which variables here are easy to solve for, and then we'll do our substitution. So I'm going to say that these are easy to solve for. I'm going to solve for my y, and then I'm going to run the rest of the steps, okay? Because you want to say y equals some function of x, and then y equals some function of x. So this one here, I'm going to rewrite as y equals x plus 4. And now I need to say, and so I've solved for my y, and here I'm going to do the same thing. I got to go, well, negative y equals negative 2x plus 1. And now I'm going to say, well, this isn't solved for y yet, it's negative y. So now I got to multiply both sides by negative 1. I'm going to multiply everything by negative 1. Get y equals 2x minus 1. Now I have two equations that are both solved for y. Now I can do my substitution. So let's substitute and make these two equal to each other. My y's are equal, so let's make the other sides equal. So I get x plus 4 equals 2x minus 1. Subtract x from both sides, and I get 4 equals x minus 1. So x equals 5, because you added 1 to both sides. So now I'm through step 4. I've substituted and solved for one variable. Now remember what I have to do to get back. I have to find my y. So I go all the way back to one of my first equations. I'll take the first one. Let's just do this step in a different color so we can see that this is step number 5. So we get x plus 4 equals y. And we know that x is 5. So I go 5 plus 4 equals y, so 9 equals y. So my answer is 5, 9. Now I'm going to do my check. When I did step number 5, I did step number 5 using this equation, so I have to do step number 6 using the other equation. So we'll do step number 6 using this equation. So I go 2x minus y equals 1. And I got to make sure it's true. This is my check step. So I say, is 2 times 5 minus 9 equal to 1? Is 10 minus 9 equal to 1? And the answer is yes. Happy cat. All right. So now I have two more problems sitting over here. And this is all, I'm just going to keep calling this homework help. So, because all of your problems are going to be like this, except for one of them. And that's going to be the problem where we have to write our own problem on the next. We'll do that on the next page. But we're going to do two more of these. I'm not going to leave you hanging. We're going to keep doing this. All right. We're going to take this guy. We're going to move him over here. And we're going to solve. Now, let's identify the variable for substitution. Which one do we think? Do we want to use the really complicated one with the fraction and the coefficient, or do we want to solve for the easier one? Well, I think we use the easier one. So let's write both of these in terms of y, and they're kind of already done for us. So I'm going to let you pause and try. Pause and try. And see if you can run these steps. Okay, so indeed, I'm going to assume you're back. So our first equation is practically done for us. So let's rewrite this one. Y equals 2x minus 10. And our second one's already done. Y equals 3/4 x minus 5. And so now we can do our substitution and say the y's are equal, so these two must be equal. So now we're on step number 4. And we say, well, 2x minus 10 equals 3/4 x minus 5. Now here's where I like to, when I'm solving, I like to get rid of fractions. So I'm going to multiply everything by 4. So all my terms by 4, and I go, well, 8x minus 40 equals 3x minus 20. See why I multiplied everything by 4? You could subtract 3/4 x from both sides, but then you end up with fractions. I hate fractions. So I'm going to now solve this guy. I'm going to subtract 3x from both sides, but I'm at the same time going to add 40 to both sides to get everything done at once. So I get 5x equals 20. So I get x equals 4. So that's step number 4. Now let's move on to step number 5. And solve for the other one. Now I know x is 4, so I'm going to make this my number 4. I'm going to use this guy. So I'll say 2x minus 10 equals y. So 2 times 4 minus 10 equals y. So 8 minus 10 equals y. So negative 2 equals y. So my answer is 4 for my x and negative 2 for my y. Hopefully this is getting easier for you. And now I'm going to do my check step in green. And so this is going to be the equation I use. All right, because I used this for number 5. So now for number 6, I got to use the other equation for my check step. So now I'm going to put both variables in and see if it works. So negative 2, and if it doesn't work, then I know I've made a mistake. And I always like to know if I made a mistake before I get my test back. So I always like to check step if it's available. So is this true? Does negative 2 equal 3 minus 5? Does negative 2 equal negative 2? And I say, happy cat. Yes, it does. Solution correct. All right. Hopefully this is getting easier for you. Hopefully this wasn't so bad. Now we'll do the last one. And this last one's going to have, there's one little trick on this last one. So if you can't figure it out, you may want to wait for me and we'll do it together. And maybe, so pause and try and solve this one here. And if you struggle right off the bat to identify a variable to solve for, watch me do the first step and then we'll keep going. Okay, watch what happens here. And this is a lot, and I'll give this to you. This is a lot to learn in one lesson, how to do substitution, and this is really substitution on steroids. So just watch me solve this one. So the idea here is that one of these, and this is where step number 1 and number 2 kind of come in. We're going to identify a variable for substitution that the coefficients are going to make it easy to identify. And I'll explain that in a second. And then we're going to rewrite equations so that the identified variable and the coefficient are isolated on one side of the equation. Now watch what I do. I say, well, I know that 4x is 4 times 1x. So I'm going to solve for x's. Because I can't multiply a number by 2 and get to 3, or a number by 3 and get to 2. So that's going to make it harder in my substitution step. So I'm going to solve these guys both for x. Okay. So this first one, I'm going to say, well, 4x equals negative 3y plus 13. So I'm solving it for my x. On the second one, I'm going to solve, and I'm going to get x equals 2y minus 5. So now I've solved both of them for x. Now I can't substitute yet because I don't have a match. 4x does not equal x. These are not equal. So I need to do something to this bottom to make it match. And the thing I'm going to do is I'm going to take this bottom and I'm going to multiply it by 4. So watch what happens. If I multiply this bottom, everything by 4, I get 4x equals 8y minus 20. Okay. And now what is cool? What is cool is I have 4x equals negative 3y plus 13. And I have 4x also equals 8y minus 20. So I have two things that are equal. Well, if 4x is 4x, then these two things must be equal. And so now I'm on step 4. I'm on step 4. I've actually made coefficients that match. And I have an equality on the left. So now let's use this equality on the right and solve. So let's go ahead and solve this thing. And we're going to move on to what I'm going to call step 4. And I'm going to say, well, the substitution is negative 3y plus 13 equals 8y minus 20. Now I'm going to add 3y to both sides, and I'm going to get my variables on the left side. So this is 33 equals 11y. So y equals 3. Now I'm going to go back to my original equation. So that was right. I'm going to go back to my original equation. I'll use this one for step 4, and I'm going to do my substitution. And I'm using y equals 3. So 4x plus 3y equals 13. So 4x plus 3 times 3 equals 13. So 4x plus 9 equals 13. So 4x equals 4. So x equals 1. Sorry, this was step 5. This is my substitute in and solve. Now step 6. Step 6 we'll do in green. And we'll use this equation. So now we're going to take our y and our x, and we're going to see what happens. We want to make sure that this thing is still true. This thing better be true, or we have not solved this correctly. So does 1 minus 2 times 3 equal negative 5? Does 1 minus 6 equal negative 5? And the answer is yes. Happy cat. We have solved the most difficult of substitution equations. All right. So these are your steps. Hopefully this all makes sense. This is a lot to learn. That's why you have lots of practice on tonight's homework. There's like 10 problems, I think, and you need to know how to stay with it. There are lots of steps. Lots of steps. And I say be persistent. Stick with it. Stick with it. You're going to feel good. When you solve it and everything comes together, you're going to feel good. Just don't fret. Work through it. If you miss one gets really frustrating, just move on to the next one. If you get most of these right, you're doing great. This takes a lot of practice, and this takes a lot of, I can sit here and talk to you forever. Your teacher can talk to you forever, but the way you're going to learn it is to just get down and do it. All right, let's move on to the last problem, and let's remember how we do this. What I want you to do is, and this is on your homework, write an equation with 2 comma negative 5 as a solution. So your key is to 1, come up with 2 slopes. Then you're going to use the slope plus the point plus the solution to write 2 equations. Okay, so now you try. Pause and try. Okay, so let's do it. I'm going to say let's use a slope of 2 and a slope of negative 2. So in one case, we're going to say, well, y equals mx plus b and y equals mx plus b. And we know what our x is and our y is, and we know what our slopes are. Okay. Left side, 5 equals 2 times negative 2 plus b. 5 equals negative 4 plus b. B equals 9. So if our slope is 2 and our b is 9, y equals 2x plus 9. On our right side, represented by the orange color. Y equals, oh, we know what y is. 5 equals -2 times x, which is -2, plus b. 5 equals 4 plus b. B equals 1. B is 1, m is -2. Y equals -2x plus 1. And we have a system of equations with a solution of -2, 5. And with that, I'm going to go with a spinning happy cat. I'm going to come back over to the Hangout, and I'm going to say, this may be the hardest or the most information that you have learned in a given lesson since I've been teaching you Unit 4 or the entire year of 8th grade math. There was a lot in this lesson. Practice is key. I'm going to hope that your teacher spreads this lesson across 2 lessons, because you're going to go into one more method for solving these types of equations, and you need lots of practice. Let me know if you want me to do another lesson. If you just ask someone, if any one person out there in the universe sends me a request on YouTube and says, hey, do a second lesson on lesson 27 and do 5 more sample problems, I will happily do those for you. Let me know. And we'll put together a 27B. All right. Whoops. You're welcome. I'll see you next time. Hopefully this was useful. Take care.